think we're good to go. Okay, so, little hiatus there. Absolute value. So when you see those words, absolute value, what the absolute value is, and I don't know who decided that this was a good decision or whatever, but absolute value are these two vertical lines. So sometimes it's a little confusing, especially if your handwriting isn't great, because a lot of times they end up looking like ones or L's or something like that. So its absolute value is little lines around like a number. So let me show you a little space down here maybe. So maybe I'll do it up here. So like the absolute value of 4. So if you write that poorly, it looks like 141. But it's saying the absolute value. So it's basically saying how much is it worth. So when we're talking about 4, it's just, the value of 4 is just 4. Where it gets tricky, so then you just write it without the absolute value. So if you ask yourself that question, kind of a strange question there. But then the absolute value of -4 is also 4. It's basically the positive version of that answer. So the absolute value are kind of treated like parentheses. So you do the absolute value first, or do what's inside the absolute value. They're grouping symbols, so it's just something we'll kind of be using, or we will definitely be using today. But we're going to review a little bit of absolute value. You might have seen it before, I don't know, but we'll kind of discern that here in a second. So the absolute value, I'll write it up here, is like the positive version of the answer. And the technical definition is the distance away from 0. So on a number line. So I'm talking about +4 or -4, we're still talking about 4. And that's how far away from 0 on a number line that would be. So in letter A here, they want us to evaluate this equation using these values up here. So they tell me A is 5 and C is -3. So I'm going to put those into my equation here. So inside the absolute value, I have A minus 7. So I'm going to do 5 minus 7. So that's the 5 is our A value. Minus the absolute value of C. So again, when I do this, I try to make the absolute value lines almost exaggerated long. So they don't look like, if you look away, you're not like, oh, that's 15 minus 71. So making sure you don't think those are ones. Now what we're going to do is absolute value in terms of order operations. It goes with the parentheses stuff. It's a grouping symbol. So we're going to do what's inside the absolute value first. So we're going to do 5 minus 7 before we do anything else with that. So 5 minus 7 is -2. Like I said, I try to exaggerate them so you're not confused about what's going on there. But that looks like a lot of gibberish right now. So I have the absolute value of -2 minus the absolute value of -3. Now I'm going to take the absolute values, because that's kind of the furthest thing out. So what's the absolute value of -2? It's just 2. So I take that absolute value, and then it says minus the absolute value of -3 is just 3. Now the absolute values are gone, because I've taken the absolute values, I changed those to positives. And they don't change to the negatives, they just stay as positive if they're positive, kind of like we were talking about up there. So now I just do 2 minus 3, and that's going to be a -1. And it's okay to get a negative as the answer because there's no absolute value anymore. So -1's an okay answer. And it's a little bit of a strange idea. We won't do a ton with problems like this. This is probably a little bit more pre-algebra-ish. We're going to solve with them today, which I actually think might be even a little bit easier, I guess I would argue. So why don't you guys try letter B. see if you guys can figure out, and that's A times C inside of there. See if you guys can figure out what letter B would be. Dante survived. He's still alive. I can't even imagine that. Like, just like this is okay to let this happen. Good. Heat lamp. Right before we left for break, we had ordered a new heat lamp, so that he'll pull his legs up and then hold it in the air. We need to, I think one of the filters isn't working. We need to fix it. It's pretty cloudy in there. All right. So guys, talking about letter B here, I'm going to substitute everything in. So this -2 is next to the absolute value. It's, oh, sorry, I should make that. So it's -2, and then absolute value, A times C. So it's going to be 5 times a -3. So I'm going to put that -3 in parentheses, just because multiplying by a negative is kind of hard to show. So I have to do what's inside the absolute value first. So I have to do that 5 times a -3. So I'm going to get a -15 inside there. Now, I have to do what's inside the absolute value. I know you might want to distribute, but I can take the absolute value of -15. The absolute value of -15 is 15. And then I have to multiply that by -2. So this actually ends up being a -30, because the -2 is kind of the last thing to happen. You're going to take the absolute value before you do any kind of like things on the outside of it. So if you had a +30, totally understandable, but it ends up being the negative. There's a few homework problems like this, not a ton. It's mostly going to be on this solving we're going to learn today, so don't stress about this too much. Like I said, it should be hopefully a little bit of pre-algebra review, but if it's not, I think you'll probably get through today's lesson okay without it. So we're going to talk about solving absolute value equations today. Now, when we go through this, we will, like I said, we will take a break, probably about halfway through here. And if we end up having a little bit of extra time to work on homework today, I'm okay with that, just so that you guys kind of get back in the swing of things. Like I said, it's kind of a rude awakening coming back from a long break. And we're kind of in a long haul here, guys. Like, I was putting up our board yet. We came in yesterday to just kind of get our bearings again after a break. But we really have a pretty big month of school, like where we're not like 4-day weeks and stuff. So like this week's only a 4-day week, so we didn't have Monday. But then we only have one virtual Friday this whole month. So it's going to be a haul here. So lots of days of full weeks. So just heads up on that. When I wrote that, that was a little disheartening to me that I wasn't Xing out a bunch of days. So yeah, so this week Friday is a normal Friday, next week Friday, and then it's a virtual Friday. So we have like 2 regular Fridays before we have a virtual. We only have like 2 more virtual Fridays for the whole year. So trying to get us back into the groove of going 5 days a week to school. But, so we're talking about solving absolute value. So when I look at a problem like this, so this x equals 10 is supposed to be kind of a problem to think about in this case. The absolute value of x equals 10. So I have an absolute value symbol equaling a positive number. So what values for x would make sense for this problem? What values could be the value of x? Negative 10 I heard, so x could be negative 10. Because negative 10, the absolute value of negative 10 equals 10. What else could x be? Another thing x could be. Could x also be a positive 10? What's the absolute value of positive 10? Just 10 again. So that works as well. So both x could be 10 or positive 10. So there's two answers for these types of problems. So tonight in your homework, a majority of your homework, you're probably going to get two answers. So, and you'll hear me as I'm checking homework tomorrow with you, like, oh, you only have one answer for all of these. The second answer is going to be really vital that you guys figure that one out. So if you only get 1 out of 2 answers, that's a 50%. Not very good. So there can be up to 2 answers for our homework tonight. We'll talk about this in a minute here. Now the next one says the absolute value of x equals negative 10. What values of x would give us a negative 10 as our answer? Kind of a trick question. If I take the absolute value, will it ever be a negative? No, we said the absolute value makes things positive. So this is a no solution type of problem. It's not possible to get an answer for x in this case because it can never equal a negative if you're taking the absolute value. And then our last one, like kind of setting these up, is the absolute value of x equals 0. What values of x would work in this one? What could x be in this case? What do you guys think? Can x be 0? Absolute value of 0 is just 0. So there's only one answer in this case. X is just 0. So one solution. So there can either be 2 solutions, no solution, or 1 solution. Most of the problems we're going to do today are going to have the 2 solutions. So just a heads up on them. These are kind of special cases. Up here, that the 2 solution is probably more likely. And that's why there's this little heart down here. Is for you guys to think about what answers work in these problems. So when we do problems like these, our first step is going to be that we want to isolate the absolute values. We want to get the absolute value all alone. Isolate the absolute value first. We're going to get the absolute value alone. If you look at the 3 problems we have right here in front of us, it's already alone. So we don't have to worry about this first step on this problem. So this is where this little heart comes in. And I use this just because it's the only shape that works nicely on the smartboard to cover things up. So what I want you guys to do is, you can't move your little heart around because I have technology there and you guys don't, sorry. So I'm going to cover that up. Oops. So I'm going to cover up what's underneath that, what's inside that absolute value. So if I say the absolute value of heart equals 7, what values could be underneath that heart? Yep. 7 or negative 7. So those are the two values that could work underneath here. So if you could pretend that you couldn't see what's there, you could say, well, that could either be 7 or negative 7. So what we're going to say is what's underneath there could either equal 7 or negative 7. We're going to set up two equations to figure out what x can be. So we're going to set up two equations in this case and then solve. Now I'm going to uncover the heart, because obviously we do actually need what's underneath there. So I'm going to not change this at all. So don't change anything about what's inside the absolute value. And that's kind of weird after our warm-up questions. We kind of want to make it positive. We're going to say 2x minus 1 could equal 7, or 2x minus 1 could equal a negative 7. So it's going to be two equations for me to solve, because that's going to give me my two possible outcomes. Ms. Miller, we're probably just going to go through these three and then go on. Yeah, sweet. Thank you. All right, are we able to solve equations like these? Should be able to, right? So kind of just keep them separated here. So I'm going to move this 1 over. So 2x will equal 8. Should have given you more space here. Then divide by 2. So x ends up being 4 is one of my answers. That's probably the answer you guys would have came up with had I not told you anything about what we're doing today. You probably would have given me that answer. I think for the most part that would have made sense. But you can't forget about the second half of this answer, because again, we only have half the answer right now. So we have to go ahead and solve this other one. And a lot of times, students try to just do like, well, if it's 4, then it has to be a negative 4 as well. It doesn't really work that way. You're going to see this here, that we actually also get a negative 3. So our two answers that work in this problem are 4 and negative 3. And we need to include them both. And they both will work if I check my solution. So just to show you guys this one. So if I check the solution, 2 times negative 3 minus 1, if I take the absolute value of that, it's negative 6 minus 1. So there's our negative 7. That makes sense. So we do need to include both answers. We'll talk about the special cases when we get back from our break. So we'll finish up these last two here though. So this next one, again, we're going to set up our two equations. Because again, you can cover up what's inside the absolute value. So it could either equal 2 or negative 2. So we're going to set up an equation. We don't change anything about what's inside the absolute value there. So we're setting up the two equations, both a positive version and a negative version. So we solve the one, we get x is 1. Now we're going to solve this other one. I don't think this one works out to be as nice of a number, so don't think you did anything wrong. That's okay. going to be 7 over 3 positive, which is about 2.3 repeating. So we get 2 answers. And it's okay if they're both positive, or they could be both negative. It doesn't really change. It doesn't really matter. It can happen either way. Alright, we'll do one more, and then I'll get this stuff online for the first half, and then we'll go outside here. Alright, so again, we're going to set up our 2 equations, both positive 6 and negative 6. Alright, a little bit different equation this time. What do we do first to get rid of, or to get the variable alone? Yeah, Justine? Yeah, let's multiply by 3 on each side. We'll do that here. Not liking 3s today. So I get x plus 5 equals 18. We'll move that 5 over. So x is 13. But then I have to do the same thing over here. So I have to multiply by 3 over here.